Welcome to the Machine Learning at Home. Today I will speak about distances. So distances are kind of machine learning object which is easy enough to understand from the everyday life. But sometimes distances which you work with might be of completely unusual nature and they might be not so similar to our everyday distances. Very frequently, two questions arise. First question is how to deal with unusual distances. And second question, how to convert distances into original data from which distances was first calculated. Let me show that on kind of artificial examples. I will create the distant object not from data but just out of nothing. So let us imagine three objects A, B, C. A, B, C. So A and B will be objects which are more or less far away. A, C also, but B, C will be close together. So it looks like B, C make natural close by pair, and A is kind of separated from both of them. In numbers it will be like that. So AC distance will be, for example, 0.8. AB distance will be 0.9, and finally BC distance will be close, 0.1, and of course the distance between object and itself, AA, will be just 0. So let me show how to make it in kind of our artificial way. So first of all we need object with name of variables. So we simply use repeat function and embedded letters objects which has uppercase letters, and so we need letters 1 to 3, and then we need to repeat each trio 3 times, and I need to show you the result, so I put external brackets. Okay, this is our result, and it's also already written into AA. Now I will create something similar but not exactly the same. So variable BB will be very similar, but in that case each of letters will be repeated 3 times, each equal to 3, and you see how it's different, right? And now I need distances, all these 9 distances, because I'm going like in a hard way, so I will do it with simply typing these distances with function C. I will type all this distance. So distance, first distance is A to A, this is 0. Second distance is B to A, this is very far away, 0.9. Next distance will be C to A, this is a slightly bit closer, 0.8. Next distance will be A to B, so this is again like B to A, exactly the same, because distances usually are symmetric. Now B to B, this is 0. Now C to B, this is very close, as I said, 0.1. Finally A to C, so this is 0.8 if I remember it right. Now B to C again, this is 0.1, and finally C to C, by definition this is 0. So this is our distances. So each pair, so this and this, or this and this, has corresponding distance. So A to A is 0, B to A is 0.9. So sounds like I made it in the right way. And now I need to create the object, the distance matrix. So to make it, first I will create a data frame. So my data frame, for example, will have a name DD, and this is data frame, which is simply consists of these 3 variables, AA, BB, CC. Okay. And I need to show them to you, so I put external parentheses. So this is simply the same thing, but in 3 columns. And we can double check CB, BC. Looks like I'm doing it right. Now we need to use function xstubs to make kind of cross tabulation out of data frame. This is a bit tricky because xstubs is not frequently used, but it's extremely powerful function, and I really recommend you to use it. So xstubs looks like a table, but table with formula syntax. So let me show it an example. It's easier to show. Xstubs cc will be dependent tilde from AA and BB, and these names will be taken from data. Data is DD, our just created data frame. So, and look what's going on. So it will make us cross tabulation. It must be symmetrical, otherwise it will not be converted into distance. I think yes, it's absolutely fully symmetrical. And this is diagonal, which is filled with zeros. Perfect. Now I will need to convert this one into distance. So as dist is a function to convert to distance object. Okay, exactly. Very simple, but we spent some time to create it. And finally, we should write it down into some new object. So, for example, II. Okay, so II is a distance. Again, it looks like that. Question is, how to work with it? If we simply apply some method to the distance, it might be not going well, because our II is something which we just invented ourselves. So I'm not sure. It may be not, for example, not a metric distance. So distance which is not laying in what statistician says not in a Euclidean space. I mean that, for example, the rule of triangle may be not true for this II. How to make this Euclidean? Actually, it's extremely simple. Simply don't forget to do it when you deal with some distances. For example, distances which came out phylogenetic trees or something else, which you're not sure is this Euclidean or not. So simply dist embedded our function to create a distances, but dist to distance. So slightly unusual way of applying it. Dist of distance. By definition, this new matrix is metric, fully Euclidean. Now you can do with it almost anything. So a very simple step, which unfortunately frequently is forgotten. So don't forget, if you're not sure if distance is Euclidean or not, this step will typically don't do any significant harm, and normally it will increase the actual, well, kind of convenience of your data. Now, like another thing which is related, how to recreate the original data from the distance. Usually, we calculate distance from some original data, from some measurements, for example. How to make it back, and especially how to make it back if original data does not exist, like in our case, II. We don't know what was original data. So, is again very easy answer, actually two answers, one very easy, one not so easy, but both of them are valid, and I will present you with both. So, well, multi-dimensional scaling is the answer, and the basic function for multi-dimensional scaling, it's CMD scale in R. But that one is applicable only to metric distances. So we simply apply it not to II, but to dist II. That's it. So this is our kind of pseudo data, original data of A, B, and C. From that data, you can see that objects B and C lay much closer together than to the object A. If you like, you can plot it and you will see it graphically. But I think it's already visible, because you see the first coordinate of A is positive 0.9, whereas in B and C, this coordinate is minus 0.5 and minus 0.4. So B and C are much closer together than to the A. So exactly what we wanted. And now, next method. That method will require my own package, so library Shipunov. Slightly crazy method, but I recommend it because sometimes, while multi-dimensional scaling is not so good. One of minuses, well, depends on your goals, of course, but one of minuses is that first column of multidimensional scaling will take most of variation inside. And this is unlikely to be the original data. Original data has variation more or less spread over columns, so it's kind of slightly less natural than you might want to want. So how to make it slightly more natural? This is a function MRH, so matrix representation of hierarchy. That function is applicable to some hierarchical clustering. So we need to make hierarchical clustering from II. In that case, we can not make distance from it, like simply use it as is. So say H clust II. And from MRH will kind of recreate original data. This is especially effective with method equal to height. So that method will recreate multi-column matrix, something again similar to the original data, which in that case didn't exist, but it's how the original data would look like if it existed, if you understand what I mean. So let us take it. So, well, if you ignore the strange names of columns, they simply so-called heights. It's okay, names of columns might be any. If you don't like them, you can replace them with anything else. So if you ignore it, you will simply see that each column contains some numbers. These numbers are numbers of clusters, and you can use these numbers as original data. So they are mostly similar to each other. Actually, all of them are similar to each other because data is very stable. But this is how original data might look like. So this is two methods which allow you to create original data, recreate original data, kind of, well, restore the meat from the minced meat. But, well, that is possible in some way. Of course, this data is not original one, especially in cases like today's one when it does not exist. So, two questions which easily solved. You can reverse your distances to original data, and you can actually normalize it. These two approaches are kind of less known than I wanted, well, to be, so please use them in your own work with data mining. Thank you very much.